and discussion. And let me quickly give you the opening remarks and introduction, and then I will hand over to our panelists. The story of I want to start with a story of a commodity product, just a pencil. Even a product as simple as a pencil will require a global supply chain during its production. Because of its multiple components ranging from the eraser, the slat, the lead, and other things. And all these will require different types of raw materials and coming from different parts of the world. So this is really a global supply chain. And if we go to the high-tech end of the spectrum, let's take a look at a drone, commodity drone that is assembled and marketed in the United States. And if you look into its components, the GPS, the Wi-Fi, the radio, the camera, et cetera, you start to see components that come from different parts of the world, from different suppliers. So this is actually a real story. So in our autonomous vehicle experiment, we noticed that there is this very small Wi-Fi chip coming from overseas with a specific vulnerability. It's almost like a backdoor that will allow an adversary to dynamically update the firmware of the entire Wi-Fi chip so that the Wi-Fi gets compromised or hijacked by adversary. He or she will be able to listen to all the communications going on between the drone and the ground control station. And this will cascadingly compromise the entire system because now the GPS, the radio communication, and even the camera operation are under the control of the adversary. So this is definitely not desirable, the scenario where one vulnerable part leading to an entire vulnerable product. So let's generalize this a little bit and take a look at the supply chain network. So in a typical supply chain network, we have multiple tiers of suppliers supplying different parts and components to the manufacturers, and even the manufacturer will have multiple production steps and the production processes. And once the products are generated, there will be multiple distributors shipping the products to different consumers. So as we have seen in the previous example, a defected component will actually lead to the defected final product, influencing the customer. And now with the manufacturing going to Industry 4.0, we also start to see the digitization of the supply chain that is also being digitized and cyberized. You tend to see IoT devices, controllers, and also the cloud being involved in the end-to-end operation of a supply chain network. And once we have the cyber components, you start to see vulnerabilities and loopholes in different parts of the system. Now we are talking about not just commodity flows, we're also talking about information flows. For example, it is possible that the source file for a 3D printer may get compromised because of some corrupted controller or corrupted network device on site at the manufacturer. Or you can also see the possibility of consumers, procurement information being compromised or leaked without consent, because of the involvement of the public or even private cloud infrastructure. So this obviously shows that a typical supply chain is, it is possible to exhibit a non-trivial attack surface from multiple angles in different facets. So now that we are in the COVID-19 pandemic situation, we have to address the elephant in the room. So this is actually a report or figures coming from a report by the Asian Development Bank on the global supply chain for the PPE, the personal protective equipment. And as you see, these are two figures representing the global flow of commodities for surgical masks and for protective suits. And you can see that there are certain parts of the country that is predominantly exporting these products. And if you look at the position of the United States, it's predominantly a kind of an importer rather than an exporter. And you will see that other countries, most notably the People's Republic of China, being the the exporter of a lot of these commodities. And this actually leads to some, very critical observation. So look at this global supply chain. It is possible that bottlenecks will be dynamically created in different parts of the network, and also there will be both economical and political implications. So by presenting this figure, I would like to make a case where the study of supply chain security needs to be elevated to a broader context. This is no longer just a technical issue. This is actually an issue that involves the technical, economical, political, and many other aspects. So in today's panel, we would like to, so my charge for our panelists, and in some sense our audience, is what I call the cosign. The challenges, opportunities, synergies, impacts, novelty, and executables for supply chain security. So let's talk about challenges in the technology, economy, law, policy aspects, and opportunities in R&D, education, workforce development, and businesses, and synergies between industry, government, academia, national labs, consumers. And also let's look at what kind of impact metric or measurement methodology can be defined to actually quantify the reliability, security, and resiliency of our supply chain system. And we will definitely love to hear new ideas, concepts, and architectures, surrounding these problems. And finally, let's talk about what we can do now. What is the roadmap? What is the agenda and action items that we can pursue together to address this very time-sensitive problem? So I would like to quickly introduce our honorable panelists. So we have 4 panelists coming from academia, national lab, and industry. So let me introduce them quickly. First, I have Dr. Gabriela Chalkley from SRI International. Gabriela is the Senior Technical Manager of SRI's New York City Research Hub, focusing on cyber analytics. So she works at the intersection of cybersecurity and data analytics, and her expertise is in anomaly detection, distributed alert correlation, network and application level security, cyber physical systems, and distributed system security. And then we have Dr. Powell Costa. He is the director of the C4I and Cyber Center and associate chair for graduate programs of the Cybersecurity Systems Engineering Department at George Mason University. He works on the applications of AI, multi-sensor fusion, and probabilistic ontologies to the safety and security of cyber physical systems. And we have Dr. Brendan Ames from Sandia National Labs. He is an acting R&D manager and principal member of the technical staff at SNL. He has led evaluation and assessment efforts for microelectronics-based systems and currently leads Prestige, an ongoing research effort to develop tools to evaluate the risk of development time system manipulation. Last but not least, we have Dr. Annika Karta, an associate professor in the computer science department at Purdue. His research builds on and expands applied cryptography, blockchain, and data-driven analysis to solve security and privacy problems in decentralized environments. He's particularly interested in understanding the interplay between improved supply chain transparency and the associated privacy concern. So now, without further ado, I would like each of our panelists to each give a 5 to 6 minute position statement. And at the end of that, we will have a number of questions that will be asked. We will hear the answer from each of them. And finally, we will open the floor for all folks in the audience to discuss and to ask questions. All right, so that's my opening introduction.
Thank you, Dong-Yang. And thank you all for being here today. So as Dong-Yang mentioned earlier, there are different topics that we would like to address today. And I would like to start with the opportunity and novelty. Actually, I'm going to cover some more now that I think about it. So I believe that it is our duty as scientists and practitioners to always search for opportunities to improve the status quo by proposing novel ideas. And we do that as a community, as individuals. Unfortunately, in the past few months, our world showed a big vulnerability of the global manufacturing operations and supply chains, like Donyang was mentioning, that led to life loss and illness. I would like to send my, I hope that your families haven't been impacted by that. And significant economical and I think mental distress across the globe. We are dealing with different types of impact. So we thus have the opportunity to propose novel, sustainable manufacturing operations that are pandemic adaptive, resilient, and secure. This is, we are on a mission here. These are topics that, together with my collaborators, Donyang and Dr. Howard Grimes and Dr. Tom Kerfus, and myself, we have discussed in a submission to Science Policy, and we are thinking at supply chain now from the perspective of pure pandemic adaptive. We have to be able to have operational modes that will easily address the social distancing, the remote working. So we have a different type of operating nowadays. U stands for usable. It has to be accessible to soldiers, factory workforce, engineers, everybody. Resilience is another keyword, and we have to be able to withstand physical world challenges such as pandemics, electrical grid failures, any kind of emergencies, earthquakes, any kind of emergency situations, and more importantly, cyber attacks, which most of the time become very similar to emergency situations. And then economical is also very important because we need resilience and security for small and big manufacturers in all this supply chain network. So we have to have security and resilience across any kind of manufacturers. So we've seen this as a way of improving the way manufacturing is done. So we need first to strengthen and diversify our supply chains and manufacturing operation. Actually, Donyang, with his presentation, illustrated the fact that we are dealing with way too few supply chain producers, right? We are, there is a new article showing that more than 50K companies around the world have one direct supplier in the Wuhan area, and those companies are also tier 2 suppliers for more than 5 million companies. That means that if one supply chain fails, one part of the supply chain fails, everything fails. And we've seen it in so many ways, right? We've seen it with the ventilators, we've seen it with the mask, we've seen it with the goggles, we've seen it with all the different equipment that was needed in this very, very hard times. So we cannot rely on a small number of primary suppliers. We have to have multiple trusted suppliers that are dispersed across the US and all the countries that we have trades with and we operate with, and we should be able to have everything done in a digital thread. We cannot, we have the supply chains cannot be done without the digital thread. And we have to have adaptability when we talk about these supply chains, right? We needed ventilators, we produce ventilators, then now we need more masks, we produce more masks. We have to have the ability to accelerate, decelerate, and more importantly, to repurpose quickly all the manufacturers in response to national priorities. Imagine that we are going to have new medication, hopefully. We are all hopeful for that. It's going to be a new drug that will address COVID-19. We will have to have a manufacturing pipeline that quickly can cover all the needs of the US and all other countries. So we recommend implementing stockpile and inventory diversity in new ways so that we have the materials, we have the designs, we have the templates, we have the data, we have the physical infrastructure needed to build everything, and we have the aggregate, and we can aggregate the technical expertise and manufacturing capabilities to have an adaptive framework. So this is the idea. So think about Again, I'm going back to the pharma example, right? If we are talking about pharma manufacturing, 1 kilogram of a precursor for dealing with one particular drug can give a large quantity of drugs. We're talking about 1 milligram per one pill, or even less than that, right? So we have to have a way in which we can store all these different precursors, and then we have to have all the designs and formulas. Those are very critical, so we have to have security mechanisms to protect all the formulas for all the medication. And then, more importantly, we have to identify, stockpile, and secure all these critical raw materials. Right, we have to have support in the legislative and executive branches to do that. And once we have all the stockpiles, we have to identify and digitally inventory the designs, the data, the templates. Everything has to be put together so that at the end we can achieve these products. And then the facilities are relevant, right? We have the stockpiles, we have the digital formulas, we need the facilities in which everything can be created. So the inventory of this infrastructure has to be done in an aggregate fashion, and it has to be extremely efficient. We have to switch very, very quickly to new drugs, to new equipment needed for protection. And the last part is to identify the technical expertise and manufacturing capabilities. This is extremely, extremely important because we have to create flexible factories. We are talking about automating the automation. We have already a factory that we have to turn it around within hours or days to produce something completely new and completely potentially, you cannot take a factory that produces, I don't know, Clorox and make it into a drug factory. You still have to stay within the same boundaries, but we have to have this type of adaptability. And security should not be the last thought. I'm mentioning it last, but it should not be the last thought. So everything has to be done, built in a digitally integrated and secure manufacturing ecosystem. It is very important to have a way of certifying that all these products are done based on norm, and to have the ability to attach a digital passport that certifies that every component was made to specification, that the assemble system performed the requisite standards. So with this, we would have a supply chain and manufacturing process that is rooted in trust. Thank you.
Thanks, Gabriela. Powell.
Okay, so welcome everybody. Thank you for attending our workshop. I'm very excited in the times that we've been through. So not excited by the bad things, of course, but the opportunities that have been raised with this whole craziness that we've been talking about. So we're all now in our homes doing a virtual conference. Would you imagine this 1 year ago? So if 1 year ago, any of you would say, no, we're going to meet in a cybersecurity supply chain workshop from our home, we would say, this guy's crazy. Well, guess what? I'm not. So we should see this as opportunity for us. The same way we are now tackling new technologies to make ourselves able to work, we can also improve the safety and security of our supply chains. We've been seeing this already. We've been seeing a lot of situations where I'm not only saying the adaptations like what Gabriela mentioned about changing a Clorox to a diaper. That was great. So I'm talking about not only changing some GM factory to do ventilators. I'm talking about rearranging the supply chains according to new criteria, according to new possibilities that were not available before. Even when this thing passes, we are still going to have a different normal. We're still going to have a situation where we can't simply ignore what happens and assume that it will take a long time until it happens again. So whatever is changing for good, and we should adapt and extract the best possible opportunities from this. Well, with that in mind, with this beginning, let me mention just a few topics from the many opportunities that we have that I believe we should explore at this point. The same way, I'm from academia, so I would say also that a year ago, I wouldn't imagine myself having to change to full online courses. Now, when I'm coming back to the normal classes, I am pretty sure that a lot of the things that we took as lessons will be applied in this new environment. Same thing for the supply chains. We had to reroute, we had to repurpose, we had to be exposed to different technologies that were not available before. And when I say we, it's the whole supply chain, and you see that effect happening. So we have to leverage that. So in the past, when you would say, what are the good things, for example, in inventory, you would say, electronic bill of materials, it's the future, blah, blah, blah. Nowadays, it's much more than that. I think the provenance that we need to have in the modern technology environment is key. So there's a lot of records of attacks being made to very complex machines, leveraging the supply chain. They say, here's this tiny component in the central brain of the machine that we can access that has a vulnerability. We cannot afford anymore to simply see that machine as a monolithic piece. We have to see as a bunch of things glued together. And as such, we must be able to trace back all vulnerabilities that are in those components. Otherwise, there's no way for us to reduce the attack surface and react to any type of attack that can come from our supply chain. So provenance can't be achieved just one or two silver bullet techniques. I'm pretty sure Anit will talk about blockchains, which is a wonderful technology, but itself cannot guarantee security for the provenance. We also have to have things such as near real-time chain negotiation, instantiation across multiple facets, multiple domains. So I have to pay attention not only to the technical side, but also the political and the costs, the energy, and have a function that allows me to balance those in a way that is almost real-time. So this has to be done, and we can do this. We can use composable AI techniques. I don't want to extend too much my talk on this, but I'm a firm believer that we are close to a point where AI stopped being a buzzword or something new, and it becomes a day-to-day activity, as we can see in our own lives. So we should be able to do that transition to more AI-enabled supply chain facilities in a secure way, and that's what we are trying to do here. Anyways, there's a lot of new opportunities and things that I would like to extend, but we don't have enough time. And I'm pretty happy that we've been here to discuss in this forum all those technologies. Thank you.
Thanks, Paulo. Brendan?
All right. Let me share my slides. Can you see them?
Yes. Yes, we can.
Okay. So Brandon Ames, I'm a staff member at Sandia National Labs. So I'm going to talk a little bit today. Now they're cycling by themselves. Okay. I'm going to talk a little bit today about sorry. There we go. About supply chains and reflections on security on supply chains. Coming from Sandia, I reflect a lot about national security and about security in general, and as that is applicable to these supply chain issues. What I wanted to start with is something you've probably all heard of before. It's called Project Gunman, and this was a project that we're referring to an effort by the U.S. government where they discovered in the United States Embassy in Moscow in 1984, or prior to that, they discovered in the United States Embassy or they got a tip from a foreign government that there was some electronic monitoring going on. So in 1984, the U.S. government very quietly and quickly replaced 10 tons of equipment in the U.S. Moscow Embassy and brought it back to the United States for evaluation. They didn't know what sort of electronic monitoring was going on, but subsequent analyses discovered that in these typewriters that I'm showing here, the IBM Selectric typewriter, there was the stabilizer bar, and then when they subjected it to X-ray, they discovered some electronics that were present in there that shouldn't have been there. It was pretty sophisticated for the time, but this is an example, or what this allowed it to do was it allowed every keystroke made on these typewriters to be transmitted to somebody who was listening in the basement and was able to record what were the documents being typed. This is an example of a system that does what it's supposed to do, because the typewriter was able to produce documents, but it did more than what it was supposed to do. How did that get in there? Well, I don't know if it was a supply chain interdiction or if it was some other means, but this is an example of a system that had been subjected to subversion and had subversive alterations. So what we are reflecting on now is we have microelectronics-based systems. We as a society depend on them in various ways, from the internet, satellite communications, transportation, cyber infrastructure, critical infrastructure, and so forth. All of these systems are very important. They're very complex. They're sourced from global supply chains, and it's very complex to try to figure out what those supply chains look like. The question that we have to grapple with is, can these systems be trusted to do what they're supposed to do when they're called upon to do so, and that they don't do anything else when they're called upon to do so? Or in other words, how vulnerable are these systems to development time manipulation? So we've been focusing on this, and I think it's an important question. A lot of focus and a lot of emphasis is on efficiency in supply chains. When we consider security, how do we deal with this? Well, we live in an age of firewalls, and we live in an age of where we try to isolate ourselves from any potential manipulation. So across a system development lifecycle, you put your finger on any one specific point. You think about, what are the things that could go wrong here? Let me keep those things from happening. Let me isolate my process to prevent attacks. So the way that we do that, you think about Captain Kirk and you throw shields up. One example of how we try to isolate ourselves is the U.S. government's Trusted Foundry program when considering the development and manufacture of microelectronic components. They have a program that is designed to certify different foundries, microelectronics fabs, that their processes have reduced or are free of any potential path for subversive alteration by an adversary. So they deny the adversary access, and you're just trying to keep the adversary out. That way they can't mess with you. It's a great idea. It's a great potential path to isolating ourselves. And it's just one example, and it's not just about government chips, but in all aspects, if you can keep the adversary from touching you, you can keep them from hurting you. So proceeding to the next slide, we have the challenge is that true isolation across the entire development life cycle, from concept to deployment to maintenance, you have ways in which your attempts of isolation may be effective, but other ways in which they may not be. When considering systems are developed from a truly global perspective, a global supply chain, you may end up with that trusted foundry being protected, but maybe you're using in your designs intellectual property that is sourced from third parties, and you can't control the provenance of that third party intellectual property. It may be that you're using Trojan hardware. There may be attempts to manipulate specifications or test routines. Some of those may be deflected by your attempts to keep the bad guys out. But at the end of the day, it's very, very difficult to simply isolate yourself out of the problem. So we can't, especially with complex supply chains, we can't isolate those supply chains from unknown manipulation, or at least unknown aspects. You know, you can't trace the complete supply chain. So the challenge is, how do you protect the unknown? Supply chains are very large, they're very complex, they span the globe, they're very difficult to completely map out. The challenge is that aspects of the supply chain may be opaque to system developers, and they're extremely challenging to completely isolate. The next challenge is that when considering from a security perspective, adversaries are really motivated. They're smart, they're well-funded, and they're very creative. That's the adversarial model we have to operate under. They are very motivated to do. Their goal may be they have diverse goals. They may be attempting to disrupt. They may be attempting subversive alterations. They may be trying to counterfeit. They may be trying to manipulate integrity. There's all kinds of bad things that they can do. System developers cannot know with certainty who's doing manipulating, where they are at, when they touch, or how they go about doing their subversive alterations, which can impact a system. And so the challenge to us as system developers is we have to, in that environment, continue to develop and deliver systems that work as expected. Number two, we can't isolate ourselves from the adversary, so we can't just put the shields up and keep the bad guys out. Number three, we cannot predict with certainty what the adversary is going to do and how they're going to go about doing it. So the question is, how do we protect ourselves from protect our systems as we're developing from subversive manipulation? And it's a difficult problem. Attackers and defenders at each other's throats all the time. I don't have answers to that. One research area that I'll just speak to just to make you aware of what's going on. I've been leading this effort called Prestige, Practical Evaluation and Synthesis of Trust in Government Systems, that's focusing on rigorous modeling of the knowledge that we do have about a supply chain or a development process. And then we apply rigorous game theoretic analysis to evaluate the interactivity between adversary and defender in order to evaluate the risks that are posed by potential adversarial interactions in order to understand risks and then make risk-informed trade-off decisions about the directions that we should proceed in. But the challenge is that in supply chains, as we continue to move forward, the challenge that we face is that we need to understand security implications. We need to understand the challenges that are associated with security in order to be able to move forward and not just consider how do we make supply chains more efficient and more effective. Okay.
Thanks, Brandon.
Yep.
Annika?
Hi, so let me get started. Okay, so probably, I think I got the control now. Can you see my slides already? Okay. Hi. Okay, so hello everybody, my name is Annika Karta. Generally, I'm interested in using the distributed systems and applied cryptography to solve interesting problems. For last several years, I've been looking into different supply chains. In particular, I do come across software supply chains and automotive supply chain, and I realized that every problem is a different problem in the supply chain space with its own interesting challenges, and I have been exploring that in general. So when I look at supply chain, I take look at individual entities in the supply chain as a unit. And then for me, the supply chain could be looked at as maybe multiple bidirectional links between all these different entities. And they perform transactions, goods or entities go from one place to other, and money flows in another direction. And then that's how you basically connect all these different bilateral links to create a chain. But what's problem typically in the current most of the supply chain environment is that we do not make this process transparent across these bilateral links. And that's the reason when there are counterfeit or there are IP issues that we come across, they could be very difficult to trace, or they, if not difficult, they may take significant amount of time before we can start detecting. And those time can result into cost and loss of good. And that's where indeed something that we can do using the computational technology. We can obviously for 10 years or 20 years, we already saw RFID tags and physically unclonable functions. All such kind of identifiers got introduced, and they are indeed really excellent tools in terms of improving this traceability. However, they by themselves actually do not make this process transparent across links. And that's where the technologies such as distributed ledgers, or as it's more well known as blockchain, comes in picture, where aim is that now you want to have one ledger which is distributed inherently across different participants, where distribution defined well in ahead or is adapted as the change is required. such that now anything that wrong happen, either we can prevent it. So that's a problem we call as the something wrong happening, which typically associated with equivocation in the our distributed system term, or we can, if we can't prevent it because of the inherent nature of the system, then you actually at least detect it in the future. More importantly, when something goes wrong, can we very efficiently within a second or within a minute figure out where things have gone wrong? I mean, just to give a brief example, let's say we have some issue with the lettuce somewhere in the agriculture supply chain. What we want to make sure that rather than waiting for a days and with lots of supplies actually going west, if we can figure out where the problem is exactly coming from within minutes, we can significantly save the timing as well as the energy as well as the supply or the goods which are involved in that case. So that's the reason these are the things which excites me working on that. I'm going to use my time to actually explain what are the challenges in this field. And indeed, as Paolo mentioned, this is not a problem that I can say, here is a computer science solution and we can solve it. There are lots of aspects associated with that, but I'm going to explain the aspects which I find interesting and challenging in this respect. And to do that, I'm going to start a very overly simplified automotive supply chain example where we have auto parts from the supplier that going to an OEM manufacturer and then dealer, and then you buy the car from the dealer. From the blockchain's perspective, in such a simple example, each of these manufacturers will introduce their own node. And as long as most of them are functioning correctly and the system is continuing to follow the logic, we'll have a complete traceability such that they can figure out how the supply is flowing. And if there is something wrong, they can just make simple queries and make it work. So in this simple example, I showed there's a supplier, manufacturer, dealers, all of them have nodes into the systems, and the system just functions very well. So that's a very oversimplified example. Let me actually take a moment to say that actually whenever I talk to people using blockchains for supply chain example, they always think about the Bitcoin mining and find them to that to be consuming lots of energy and requiring significant overload because of that. But the key thing I want to mention is that supply chain, because inherently given the scenario where we don't have a unlimited or unidentified entities which are employed in that case, we do not need to resort to technologies such as mining. And that's the reason they're certainly energy efficient, where we do not require any such heavy mining or hashing or random computations, and those lots of farms to run or consuming a lot of energy here. Now, what are the interesting challenges in this space? So I want to, there are numerous, and I want to actually talk about some of the interesting things that I can easily explain with my example. So in my example now, I'm just replacing one supplier by multiple suppliers. I'm keeping manufacturer one for now, and there are multiple dealers. You can just expect that there are multiple tier 1, tier 2 suppliers that come in picture. They feed into manufacturer, and then from manufacturer you go to multiple dealers, and there could be a kind of a hierarchical structure there itself. We can't expect each of them to have a node in the system. Okay, that they will find it just too challenging to maintain such system, and actually maybe they will not find the need for them itself. So we have to define a trust structure here. So the node says, I will not add the node, but I can maybe follow or trust a combination of nodes, and that combination could be unique for those nodes. So, and when we start looking into this process, and when we try to look at all these more complex supply chain examples, there are interesting questions come in picture. So obviously we cannot have nodes left in their case. What about IP? Now, if all the information is present in one place, then we have to indeed deal with the scenario where who can see the whole data? I mean, if everything is transparent, that's bad. Now, all of a sudden, let's say I'm a supplier, my way of trade is now can be visible with the other suppliers. Or maybe I do not want my manufacturer to know about that. So the interesting IP issues that are present there. There could be interesting compliance issue where based on how I access the supply chain, my competing suppliers or my competing dealers can know my way I use the system and can actually go and use that against me. Also, how generally can I motivate really deep part, like your tier 2 and tier 3 supplier to join the system? How can we motivate them? Maybe can we give some kind of interesting incentive for them to join so that they can earn faster than their current mechanism? So there are lots of interesting questions that we can answer in this space. And these are interesting issues where I see we can make whole thing transparent, but then there could be access privacy issue, there could be IP, intellectual property issues that we have to deal with, or how much transparency we can introduce and how much privacy we allow is an interesting trade-off that we have to pick each of the supply chain and try to answer that individually. And this is certainly something which I really interested to look into from my perspective. All right, so yeah, those are the few thoughts from my side. I'll stop.
Great.
Here.
Excellent. Thank you. Thank you all. Thank you all panelists. So before I start the Q&A, I would like to invite maybe Brendan to quickly respond to a comment/question from Paul. So he wrote, in the case of gunmen, one could have put all the electronics in rooms that were Faraday cages, as overly simplistic example. That might have been less expensive and sophisticated than supply chain assurance from top to bottom. Isn't there a need for simple economical solutions rather than pervasive, expensive ones?
So, sure. Number one, acknowledging the fact that there has to be a balance of the economics. We have to, let's not drive to the more expensive solutions if there are simple ones. The challenge that they were facing at the time is they didn't know what the problem was. They didn't know if it was electronic communication, or they didn't know the nature of the problem. And so it was basically a stab in the dark to say, all that they had was, hey, there's some espionage going on. You got a problem. Okay, let's try to sort out what can we do. And the problem with a pervasive unknown adversary, until you can diagnose the problem, you can't go with a simple solution that you think might solve the problem. So, I'm not saying that wholesale replacement of all electronic equipment is the right answer every single time. But what do you do? I mean, that's the conversation that the community needs to have, is what do you do when you don't know?
Great point. Thank you. So I would like to invite folks in the audience. If you have a question for the panelists, please start typing in the chat area. And before I see those questions, I do have a list of prepared questions that I will ask the panelists, and I will invite each of them to give us his or her answer to that. So I would like to start with a simple one. So for each of the panelists, will you please identify the biggest technical challenge in your opinion that needs to be addressed, with the highest level of urgency for securing supply chains? Let's start from Gabriela.
So I can refer back to what we are living through nowadays, right? And the fact that we need this adaptability. So when we talk about adaptive supply chain, that means that the security mechanisms that we have to be adaptable. We will have to deal with different granularities at which we monitor and we secure everything in the supply chain. We will have to deal with small and larger suppliers, and for all of them, we will have different instrumentation levels. How can we build such a supply chain that addresses all the needs and at the end gives us enough information to understand if the products that come out of the supply chain are reliable and secure at the same time. So I think this adaptability is a big technical challenge, but we have methods to overcome them. Annika was talking about the blockchain. The blockchain can give us some good ways in which we can adapt ourselves. So putting together different technologies like that can lead to a full supply chain which is secure and adaptable.
Powell, you are muted.
Yeah, I think you can hear me now. Right. So yes, I would say adaptability, yes. But my main concern nowadays is really data provenance. I mean, being the high capillarity of the multiple attack surface that we have in complex systems make them so vulnerable that if we do not really track down to a high level of provenance, it will be very difficult to prevent attacks. So that's, for me, the major challenge at this point.
Thanks. Brendan? Brendan, or go ahead.
Okay. So I think you know, I alluded to this in the talk, but the challenge is dealing with a high degree of uncertainty, the complexity of the supply chain. You know, there's the debate about whether we should just live with the fact that it's impossible to map it out completely and therefore know what the risk is. Or maybe there is ways that we can go about trying to evaluate and understand the risk with partial knowledge. But if we had the ability to develop, you know, rigorous integrity checking mechanisms that could test the end product of the supply chain and thereby eliminate the need to evaluate the provenance of the system, you know, that'd be great. But I don't know that we collectively know how to do that effectively. But being able to make risk-informed decisions in the absence of detailed knowledge about the structure, the composition, and who has access to what in that supply chain, I think is a big challenge.
Thanks, Brandon. So I guess from my perspective, I'll start from where Paul mentioned, that to having a provenance, and I'll add an objective to that, and that is the fast provenance. If we can figure out the vulnerabilities or the missing links for a given situation, for a given question faster, that can significantly help us to actually solve the problem well in advance, or at least in real time. And that I find is the key thing that we have to do with the secure chain. It should not involve talking to somebody and they talking to somebody and they talking to somebody, a human chain of communication before you figure out the problem. If I can do something sitting at my computer and figure out that where the problem is exactly happening, to whatever extent that's possible, that can significantly help. And that certainly, I think, is the important thing that we will like to achieve, is the fast provenance.
Thank you. So Brian from the audience asked a very good question. What common solutions might apply in both the hardware and software spaces? Many of the proposed solutions are aimed at one or the other domain. So any common generic solutions in the software and hardware spaces, in your opinion?
What Annika was proposing, right? Putting together, it doesn't matter that you are building software or hardware, having the ability to collect all the information and having the ability to leverage the blockchain is something that is common across both of them, right? It doesn't matter what you are building. You can build also, posters and something else. So that's one common thing for both software and hardware.
Yeah.
One thought in the security domain is that you know, if an adversary is attempting to manipulate an end system, they want their actions, they want to know that their activity, the risk that they take to attempt to undermine one phase of the supply chain will have the intended outcome at the end that they want. If you deny the adversary the opportunity to accurately predict the outcome of their actions, it might have a deterring effect. And so this is something that's, you know, it's not something that I'm coming up with, you know, it's been studied. But the integration of diversity and diversification, you know, this is a, you know, somewhat speaking heresy, but you're trying to integrate a little bit of randomization within your supply chain and denying yourself the opportunity to predict with accuracy what that supply chain looks like, with the benefit of denying the adversary the opportunity to predict with accuracy what the supply chain will look like. That could give you a benefit, but that's agnostic to hardware and software.
Yeah.
Okay.
Yeah. So one thing I wanted to mention quickly about, so indeed hardware and software is many of these things. Somehow I find software to be a bit harder because easy to copy and very difficult to associate an inherent identifier. So there are interesting material-based physically unclonable functions or identifiers that we can associate with hardware, but they could be extremely hard when it comes to software. We can use watermarking, but we don't have like foolproof solution in that space. But still, similar techniques, as they mentioned, could be useful. But software is a bit harder somehow.
Joseph has a very interesting question. Isn't blockchain technology subject to the same supply issue as manufacturing, with more of the world's block mass computers in PRC, for example? How do you prevent an attack there?
So maybe I'll just get started. So actually, that's the thing, right? For such a technology, the technology that or the blockchain that we can use in supply chain environment doesn't need to rely, or they do not rely on such mining technologies and those computers at all. These are what we know the standard distributed systems that we have been studying here in US for several years, where the aim is that you require those machines because you do not want to control who joins. But in supply chain environment, we fix who can join. And in that case, we not at all require such computing environment. We don't need to wait for 10 minutes to agree on something. Everything is instantaneous as long as what they can perform as a Byzantine agreement that we can perform between the nodes. So that's certainly the important thing I would like to emphasize, that we don't have to rely on the computing capabilities or the huge computing capabilities when we talk about employing blockchains for supply chain environment.
Anyone else? Panelists? Any other panelists who would like to chime in? If not, let me move on to the next one.
Let's move on.
Supply chain concern is still largely driven by governments and defense applications, while COVID might drive civil interest in supply chain availability. How can we build interest in component integrity in broader swath of the economy? That's a great question, Brian.
I was mentioning earlier this idea of a passport that comes with every product, right? We have to have the ability to fingerprint everything that goes into a product. We have to be able to track everything that goes into a product. So all that information can be captured into a digital passport, the way we have passports that identify us and also track all our movements throughout the world, not anymore now. The same way we can do for the supply chain. The same way we can use cryptographic techniques to ensure the integrity of the information that is captured in these digital passports.
Anyone else?
I think one thing that you can consider is you look at, say, the modern cell phone, and the cell phone companies, one way that they get around people trying to reverse engineer their devices and replicate them and introduce them and take market share away from them is they speed their development process up very quickly, and they turn around new products, and the product lifetime is very short. I think that one thing that we all ought to acknowledge is the fact that, number one, there is a strong desire on the part of the, whatever aspect of the market to be able to steal market share away by producing counterfeit parts. Mark Tronapour in his keynote this morning was talking about counterfeits a little bit, and that is a significant economic impact. Companies do have to actively defend against counterfeiting going on, and I think there is a strong motive to that. I just don't think that the broader public that's going to the grocery store and not seeing toilet paper on the shelf, they aren't as aware of the counterfeit going there. And if it's an effective counterfeit, you don't even know. But I do agree, we do need to understand, how can you detect a good effective counterfeit other than, well, it broke after a year instead of it broke after 10 years. Something along those lines. But that's a great point. We do need to figure out how to improve the integrity.
Exactly. So the next question. Oh, sorry.
I would just say that there are different, like Brandon is mentioning, there are different criticality levels for all the different products that are going to be generated on the supply chain. And in some cases, the criticality is not that high, so it doesn't matter as much, the integrity, because it doesn't have an immediate health or any other type of impact. But in other cases, the criticality is so high that integrity has to be the focus of the supply chain.
So Lorenzo has a question for Paulo. So Paulo, you mentioned that we are likely to see integration of AI in the supply chain. What are the risks of pushing these kind of technologies too soon without having sufficient clarity in the explicability or explainability of results?
You're muted.
I'm very good at that. All right. First, it's a great question. Second, there are risks, and many of them as you can imagine, putting an implementation of any new technique to the supply chain is risky. So I think the key thing to have in mind is that as we have the risk of implementing too soon, we also have the risk of not implementing. So in the end, it will be a balance. We cannot afford not implementing, because someone else will, or the enemy will leverage the fact that we are not implementing. So I would say when you take this into account, is really it depends on which case. We cannot simply have a silver bullet solution to implementing this speed. No, each specific technology to each specific domain will have an implementation speed, and that relies on the culture of the organization, relies on the complexity of the linkage of the nodes in the supply chain. So many of those aspects have to be taken in consideration. But I would say there's no way that it's always involved risk, and I refer back to Brandon. He was saying this. In the end, what really matters is for you to do an informed solution that takes into consideration what is the right balance of risk in your implementation.
Thanks, Paulo. So the next question comes from James. The organization that I recently left started adding language to its contracts that included supply chain, and that anything related to a security incident would hold them liable to a 5 million per instance occurrence. Do you feel that changes like this will hold manufacturers, vendors to a new level of accountability of both software and hardware supply chain quality?
Yes. It's a short answer. Yes, it's a but do we have the technology to do that at the moment? That's a question to all of us, right? Can we give full guarantees for all the products that are coming out now? The answer is probably no. So we have to build technology where we have these strong guarantees, so that we can offer products with liability as a community. So it's a fair question, but I don't think we are there yet, and we should be there. We should work towards that. I think we are all trying to work towards that goal.
I think a short answer is without accountability, there isn't going to be any progress in this area. But at the same time, I don't know that a contract like that would be enforceable, because how can you establish and guarantee attribution that it's the supplier's problem, not the supplier's supplier problem? But then again, on the flip side, a requirement like that could drive innovators out of the marketplace because of the liability that you have to assume in order to be able to engage in any offering. And so we have to be careful with that. In absence of really good integrity checks or being able to establish provenance with confidence, that's just simply, I'm going to sue you because I can. So there's challenges there, and I don't know what the right answer is, but it's a great question. It's a great thought.
Yep, I agree.
Yep.
Any other comments from the panelists?
No.
So let's move on to the next question. So Juliana asks, a very small percent of business attempt to be transparent about their supply chain. This is usually advertised as a premium feature for expensive brands. Do you think these efforts can be generalized, or does the push for transparency need to totally come from scratch? Who should drive this effort? Is it government or the public? Transparency of supply chain, like explicitly spelling out how the parts where the parts came from, et cetera, if I understand correctly.
The public will not have enough influence. I think it has to be on both sides. I think the public can request that, and the government can support with legislation and rules, right? We think about, I'm going to give an example in Europe. Think about the food products in Europe, right? In Europe, you are required to write anything that might have a health implication on all the products. So it's a matter of combining the public and the government support in getting to achieve this.
Yeah, so I'll start from where Gabrielle is. Indeed, I guess it's something, once somebody does it, probably that can help quite a lot. So let's say I go to a store and I buy organic, let's say, and it says it's organic. And currently I just rely that, hey, it's written organic, so it's better be organic. But if I have a barcode there that I can scan from my phone, and if I can show me how actually has come and why it's organic, probably vetted by some people, or if it gives me more information, I could be more inclined to buy those products. But indeed, we are yet to see that happen. And as I saw with like what happened in terms of the privacy when it's come to browsers like Chrome's and all the Apple products, I think when somebody does it and people value it, then it can motivate even other people to do that, even in the public space. But indeed, if government does that, even better, because then it can enforce that at different level. I think from computing perspective, we are there to offer such solutions, but indeed we have to make that push to make it as close as to the reality. But indeed, more efforts are required in that space.
Yeah, I believe Juliana's question is really about trust. I mean, just to use Annikat's example, when I buy something in the supermarket and I say, oh, I want this because it's organic, how can I trust that this thing is really organic? And how can I trust that the barcode ensures me that it's organic? So then I see that there's a label there about that guarantees that this specific supplier provides really organic product. Well, that enhances my trust and makes me more willing to buy that specific part. So in the end, it's a market of trust. And I would say that, as Gabriela mentioned, it's a mixed solution. You have to have those organizations that do their stamp, that this thing is really alleged, but you also have to have the public being interested in buying those things because they are more trustful.
There's a lot of similarities in this question to distributed ledger technologies and the fact that could maintain a historical record of who participated in this, whether it's the name of the company itself or some hash of it or something along those lines. But if we advocate an approach where that is visible to the public, that is tantamount to the same thing as the ingredient list on the food that you're purchasing, and that's got to be a good thing.
Yeah, and the same thing with explainability in AI, right? You want to see why you got a particular result. It's the same idea.
All right, so let's move on to the next question. So Mark asked, it's a comment/question. An industry standard backed by open source tooling for creating bills of materials can go a long way towards improving software quality. I personally agree. For hardware, I'm not sure what the corresponding solution will be. So any thoughts from our panelists?
The first thing that comes to my mind is 3D printing, right? It's the way that if I have available the recipes for the tooling, that would make my life much easier. But I defer to people who actually understand more about 3D printing than I.
No more comments from?
Well, so if we're talking the 3D printing, no. If we have somebody who is an expert in the 3D printing part in the audience.
Sure.
Yeah.
Okay.
So I'll just add that with hardware identifiers could be added. And so the one thing that can happen again with the blockchains is that if somebody steals my identifier, that's not good enough to launch an attack. I mean, if identifier is already in use, and if you try to introduce a new fake product with the same identifier, I can catch it. So given that, as long as we can generate identifier, and that's where the standardization effort has to happen, and they are happening, then we can say that at least the hardware part could be bring to the same level as open source.
Thank you. So Paul just quickly asked, don't some businesses regard their bill of materials as trade secret today? This will have to change. Your thoughts, comments?
I'm sure some companies regarded their ingredient list on their food as trade secrets as well, but I don't. I think
Coca-Cola and Pepsi.
That's what we need.
Yeah.
Yeah, I don't want to be just one thing person, but it's again trust. Like Coca-Cola, I trust drinking Coca-Cola even though it's not open. I wouldn't trust some new cola if it was not open. So it's something that we have to consider when requiring. I don't believe that just forcing the bill of materials to be open is even feasible. But I would prefer to go to a solution that has an open bill of materials than one that has a closed bill of materials.
So if you can actually, you don't need to make it, you don't need to make it public, but you can extract information from it that is relevant for the public, right? If you want a particular guarantee, then you can refer to that particular guarantee. So there is another way in which you can do an aggregate information out of the bill of materials potentially.
All right, so the next question comes from me. Do you see any new or unexpected opportunities, right? Not challenges, right? So I call this the silver lining for the manufacturing and supply chain industry in the post-COVID era. So what are some of the new opportunities that now people realize as a possibility or as a potential opportunity for revenue generation, for example, the good side?
Well, I wouldn't say revenue only. I would focus on a broader kind of a good things. So, for example, I think we mentioned here already the cultural acceptance of online procedures that we were not used to do in the past, and now it just became the norm. Another thing is the increased awareness of the technology possibilities. How many of us were so familiar with Zoom and other solutions? So this is now kind of disseminated. It's something that we can leverage when we come back from this whole quarantine thing. It's going to be there. It's something that was culturally changed. Another thing more related to the supply chain, I believe, is this diversification of the supply bases. Because we've seen a lot of our suppliers closing and we had to find alternatives. Well, we will be surprised to find alternatives where we wouldn't think if it was not for being forced to look for. Another term in the list is the exposure to new approaches to engage with commercial partners, different ways of selling your own product, like restaurants, instead of having people down there, they would reinforce the options that they have of offering food online. Just go there and pick. Also, another variant of this is this more creativity that people are having, the suppliers specifically, on rerouting, repurposing, and everything. And lastly, I would say that all this has been a great test bed for us to get lessons learned. In talking about lessons learned, I've seen some pictures in the internet about the Spanish flu in 1920 with people using masks and everything. Things that I learned, well, toilet paper was not a problem. But a lot of the things that we see happening today happened in the past. So somewhat we lost a lot of these lessons in those 100 years. So I hope we learn now that we should keep better our lessons learned so it doesn't repeat again.
Donya, Greg would like to add something to this question.
I would like, yeah, so if possible, Natalie, maybe we could let Greg speak. So in the remaining 15 minutes, we would like to actually open the floor so that folks in the audience can also speak up and be heard. I believe this is technically possible. And so At this time, we would like to have a more free form of discussion. If you have any comments, not just questions, or opinions that you would like to share with the audience, I would like folks to do that in the next 15 minutes. So I very much love to hear Greg's comment. Natalie, would that be possible?
Can you hear me?
Yeah.
Yes,
Yeah.
now I can. Perfect.
Excellent.
Greg, please.
Technology works occasionally. So thank you, Dong Yang, and thanks for you all for this panel. And I love your question of what's the silver lining. I think the silver, it's hard to say it's a silver lining really, but it's where what's the type of innovation that might come out of this. Because I think, I've talked to Tom Kerfus about some of this. One of the challenges is what's a business model that makes sense. Resilience is a grand idea, just like security, but how is it really sustainable from a business model? And I think what you might see is that some businesses will configure themselves so that they can sell resilient capacity that can be made available on demand, even though day-to-day it's not really being used. Part of the challenge is how do you ensure that capacity is really there? How do you verify it and validate it? But with the right sort of infrastructure, you could have, kind of an audit or dry runs once a month or once a year to say, yep, you need a ventilator in 24 hours, we can do that. And we did one yesterday and we'll do it again next year. And I think that would create just some amazing resilience. And, you can sell that capacity, that capability is kind of like reinsurance markets almost. It's kind of the backup to the backup that that it can be pulled on demand and it's been priced in the market. And so people can make investments, there can be research, there can be innovation there. So anyhow, I love the question. I think there's going to be some really interesting business models that come out of all this.
Thanks, Greg. Great points. Any follow-up on this?
So there was one thing which I heard talking to a management science faculty at Purdue once was that this manufacturing on wheel, where the idea is that maybe indeed, certainly for scenario like this where we have these PPE requirements, I guess having a cloth mask, if you have a sewing machine and clothes, probably many people can try or successfully make it. So that's just a simple example, but indeed having manufacturing where we are not relying or supply chain infrastructure, we are not completely relying on stationary big company and big project, and rather than facilitating anybody who wants to participate in such environment through small on-moving environment could be something that is possible in some aspect. We probably can't do that for ventilators, but we can certainly do that for PPEs and things like that. So there are interesting possibilities which can happen with those kind of things.
Excellent. Paul has a question. Is it sufficient to be able to find the broken trust or the broken links in the supply chain as opposed to the actual transformations of a product down the chain? Just doing some diagnosis or kind of pinpointing where the broken link or the weakest link is. So that's more of
it depends on the product, right? So for example, I don't know, let's think of two different products in which if you have a broken link, that's it, you trash the product because you don't trust it anymore. Let's think about drugs, right? If you touched anything or you added something extra into a drug, that's it. The link is broken and you cannot reuse that drug. With the actual transformation of the product down the chain, if you have a way of reversing that transformation, then it's a recoverable product potentially. And I cannot think of a particular example. Hardware probably is not going to work, but maybe for software we could think of some reversible transformation that can still save the product, and you start from there. Actually, you can think. I have an idea. So think about an application that is running and then it's reaching a point where it's broken, right? And then you can reverse the actual process somehow and start from a clean slate. So maybe, yeah, each of them has a different role depending on the product.
Good point. Thanks. I saw that Wayne has a comment. Wayne, would you like to actually speak up about what you wrote earlier? I'd like to know more about what you wrote there.
Oh, I just thought I'd just post it and just.
I know. Yeah. Elaborate, please.
I mean, there are some complexities with bill of materials. Certainly, there are some efforts, I think, even posted here to create both software and hardware bill of materials. In some sense, I'm shocked that we don't want to progress there sooner, because I don't like living in a shanty house anymore. I have a bill of materials and architectural standards and fire code standards for the house I live in, and I think that we've evolved in digital technologies where we probably should expect the same thing. But reality is it will take time to evolve, given we don't want to crush innovation and other things. Certainly there are approaches where you can characterize unsafe behaviors in code segments and other things that may or may not be a supply chain risk, but it can either be a supply chain risk or a vulnerability that you don't want, or a reliability problem. And I think there's some efforts from CITL, from Mudge and others that are starting to progress towards that. And particularly as we get into these automated tools, like I think were presented in some of these forums, that becomes an interim measure as we work towards, like what Gabriela described as maybe some form of a multi-dimensional passport or these idealized bill of materials. So that was just my thoughts.
We have Ginger who wants to who wants to respond to this.
You're muted, Dong-Yang.
I was. Go
ahead.
ahead.
This is Ginger, right? Hearing Wayne's question, I simply wanted to observe that, Wayne, I like the place that you are going, and I hate to take the food label analogy too far in terms of software supply chain or hardware supply chain. However, the allergy section of a food label is an important thing to think about. I cannot predict what you might be allergic to in terms of risk, especially where you may have made choices with your hardware or software that have certain included components. Those same components represented elsewhere may manifest as an allergy for you, where someone else who had a more diverse outlay might not have the same allergy. So that's the one weakness of trying to characterize without that specific context what might be bad or good in terms of a nutrition label.
Thanks, Ginger. So I would like to kind of slightly change gear and talk about education and workforce development. So what kind of challenge and opportunities or inadequacy you see in the aspect of education and the workforce development, especially in response to crisis or unexpected events, black swan events like COVID that we are experiencing?
I think the black swan events basically make things worse in terms of, for example, talent acquisition and retainment is a big deal. It was made worse by the event, but it was there already. So there's solutions such as, talent as a service, you hiring outside groups and merging to your internal groups. As a temporary solution, understanding that your own group will be able to walk alone later. And also in this very same environment, we see the growth of online platforms that are really making a difference in terms of breeding new talent. So these things were already there. It's just that now with the Black Swan event, we simply see a much higher need for them.
Other comments, thoughts? So last question. So there is a question from Ray Shen. How would you characterize risk when the probability and impact are not well known? like quantification of risk, the definition of metrics and the quantification?
So I've reflected on that one a whole lot, considering development of risk assessment approaches. At Sandia, we deal with high consequence systems frequently, and the challenge that you get in with the standard risk equation of calculating probability of occurrence, coupled with consequence. How do you calculate the probability of occurrence for a rare event? And it becomes very, very challenging.
Yeah.
And so some of the efforts that we've tried.
We lost Brendan?
Yes.
Yeah, I think we lost Brandon.
Yeah.
Oh, and I was curious to hear what he was saying. Oh my.
Okay, probably.
Does anybody know in which direction Brendan was going?
I was really interested because I was going to say when you do not know, usually you try to resort to mathematical tricks such as intervals of confidence and this type of stuff. But there's also something that doesn't make your life easier. So I was curious with what he was saying.
So there is another area of uncertainty, right? Because I think there is the uncertainty of what can happen in a particular system and so forth. There is an actual complete field on this uncertainty analysis and so forth. I'm not an expert in that, but I know that people are analyzing it in the Internet of Battlefield things, because there you have uncertainties that come from so many areas. So you have uncertainties on the communication links, you have uncertainties in the data that you receive, you have uncertainties at so many different levels. And I think even in the supply chain, we can see the same kind of uncertainties that can happen, right? What if you have a broken link? You may have redundancy, but you had a complete power down issue, and then the products have been done, but you didn't collect all the information. You don't have all the instrumentation. Do you trust that product? You not trust that product. So there can be interesting risk factors in rare events. Brandon was mentioning the rare events, so yeah. I'm trying to go with an example with rare events.
Yeah, so before Brandon crashed it, I was actually going to mention this in terms of the rare events, but also because risk and probabilities are tightly related, but they are different in terms of the risk also relies on other features. So the probability will tell me how likely an event is, but risk also takes in consideration how much damage, if that event happens, I will have. So in the end, even if I have a bad track of the probability, but it's not really something that hurts me, I can still deal with that. But when I get high damage in improving probabilities, that's the area we want to avoid.
So so I realized that there are 2 minutes remaining for the panel. So to wrap up, I want to ask a very kind of a forward-looking question. So now we're gathering to actually talk about supply chain security. So in the future, maybe 1 year, 2 years, 3 years, 5 years down the road, when we reconvene, what is the most important metric in terms of supply chain security, resiliency, reliability that you would like to see improved with the lapse of time? Give me just one specific metric, because I think we need to actually quantify and measure our progress, right? If you want to see progress, what would you like to see, in what metric you would like to see the progress?
I like Greg's suggestion with agility. I was thinking about a word similar to that, going back to this COVID-19, right? We have to be able to transform a system within a day, within minutes, within hours. So having a metric that can capture that adaptability aspect of a pipeline could be very relevant.
Yeah, for me, that would be resilience in terms of how can I trust that this guy will stay there when I need him? And I don't see today, we talk about a lot on resilience, but there is no real metrics established on what resilience means in a broader aspect. So I would like to see that change 1 year from now.
Yeah. So I'd like to add to that the speed that I want. It would be great if we can find out. We still figure out what went wrong, but if we can do that with speed, or maybe figure out even well before that happens, that these are the things which could significantly help to us to not fall prey to the situation sometime that we come across right now.
Excellent. Anyone? One last. Go ahead.
This is Brandon. I got back on.
Yeah.
So the thought is that, you know, it's so challenging in the security side of things that we don't even know how to measure. So maybe even just the presence of well-defined metrics at the end of this period. But some of the things that I would love to see risk go down, but I'd love to see us be able to have quantitative and objective means of assessing that risk. But also maybe something that's a little bit more easy to put our fingers on is the number of counterfeits that are existing in the market. If they go down.
I like it.
Yeah.
Wonderful. So,
there is one thing I want to. So Brandon, you're mentioning very nice thing about this risk and probability. I know we don't have time, but if you can type in yours, so we all were curious to hear your answer.
We were like, oh my God.
So maybe you can type in the chat window. That will be great.
So let's continue to do that on using the chat box for the live panel. This is really great. I have a lot of fun. This is a great panel, great audience, great questions, great comments. This is excellent. So with that, we wrap up the first panel on supply chain security and resiliency. Thank you so much, everyone, our panelists, our audience, and our organizers. And we do look forward to having future opportunities, future gathering of this kind to continue to discuss this very important issue. Thank you very much.
Thank you.
Thank you. Thank you.
Bye.